today we are building something massive, a full-stack AI-powered career coach that generates 12-month roadmaps and gives you a personal mentor named Jake. Let's not waste any time and dive right into the walkthrough. When you first log into the app, you'll be asked to onboard by filling in details about your career path. This ensures the AI generates a plan tailored specifically for you. Once those details are in, we hit that Generate My 12-month plan button. This sends a request to the Gemini AI model to crunch your data. Within a few seconds, you get a detailed monthly breakdown. Each month contains a sub-detail or a focus area where you can keep track of your progress. We also have Jake, our AI career assistant. Jake uses the same Gemini AI to understand your career context and offer advice or answer follow-up questions. These are the core features, and there is so much more to cover. Stay tuned for this in-depth tutorial. Before we dive into the technical setup, I want to give a quick shout out to Hostinger for powering this tutorial. When it comes to hosting, reliability and performance are everything, and their VPS hosting is a total game changer for developers. Whether you are running a simple web app or a complex Docker containerized system like the one we are building today, Hostinger provides a seamless, high-performance environment with full root access and Ubuntu support. It is an incredibly affordable, all-in-one platform for managing your domains and servers. If you are ready to take your own projects professional, I have a special deal for you. Head over to Hostinger and use the coupon code ALBERTAI at checkout to get a significant discount on your hosting plan. It is the exact service I use to keep my applications running fast and 24/7. Now let's get into the system architecture for this project and set this up from scratch. Let's dive right in and break down the architecture for our modern full-stack application. This is the bird's eye view of how every piece of our puzzle fits together, from the user's click to the data sitting in our database. First, we start on the far left with the user layer. Here, the user interacts with the browser or client, sending out HTTP requests that hit our frontend. Moving into the green box, we have our Next.js 16 app. This is the heart of our interface. Inside the app directory, we have our main page.tsx file. This is where we handle our state management. We have several key components here: the plan section, the onboarding card, the Jake chat panel, and our navbar and header. Under the hood in the front end, we are using a Clerk provider inside layout.tsx to wrap our app in authentication. We also have a central app state that keeps track of the user profile, their plan, and the chat history. To keep things secure, we have a middleware.ts file sitting at the edge, intercepting requests to ensure only authorized users get through. Now, look at the flow to our external services in the orange box. When a user signs in or signs up, our app communicates with the Clerk Auth service. Clerk sends back a user ID and a session JWT, which we then pass along to our backend. In that same external services box, we have the Google Gemini AI. This is the brain of the operation. It receives messages and context to generate Jake's replies, and it also handles generating those custom 12-month plans. Next, let's trace the lines to the backend APIs in the pink box. We have three main endpoints here. First is post/API/plan, which receives the plan JSON from Gemini. Then we have post/API/chat, which handles the back and forth reply text. Finally, there is a get and post/API/state endpoint. This one is crucial because it syncs our app state JSON with the rest of the system. Finally, on the far right, we hit the database layer. Our API routes connect through a library folder using the file mongodb.ts. This establishes the connection to our MongoDB Atlas instance. All that data ends up in the user_state collection, creating a persistent loop for our application. And that is the full flow. We have got a clean, scalable architecture ready for production. I hope this walkthrough gave you a clear picture of how these services talk to each other. Now, let's set up the project. Open up your favorite code editor. I am using Cursor AI on the left side, and on the right, I have the browser open so we can see what we are building in real time. Let's open a new tab and search for Nextjs Shadcn. On this website, we are going to copy the create project command. Now, back in the editor, let's open the terminal by hitting Ctrl+tilde. Paste that command and hit enter to install it. Just select the default options for all the prompts that come up. Once it is finished, you should see the message Success, Project Initialization Completed inside your terminal. On the left-hand side, you will see our new file structure. First, we have the source folder containing the app directory. Think of the app directory as the heart of your application. It handles all your routing and organizes your different pages. Inside that app directory, we have the layout.jsx file. This file acts as a wrapper for your entire application, allowing you to define UI elements like navbars or footers that stay the same across every page. Next to it is the page.jsx file. This is the actual unique content of your home route. It is what the user sees when they land on your main URL. We also have a lib folder containing a utils.js file. This folder is a dedicated spot for utility functions, reusable pieces of code that help with things like formatting dates or merging CSS classes. As we progress through this tutorial, we will explore more of these files in detail. Now let's get this project running. In the terminal, type cd followed by your project folder name, then type npm run dev and hit enter. This will start the local development server on localhost:3000. You can hold command and click that link to open it in a new tab. And there we go. We have the Next.js boilerplate code fired up and running on the right side of the screen. Now that we have our project initialized, it is time to handle the most important part of any modern app, authentication. We are going to use Clerk, and if you have not heard of it, Clerk is a complete user management solution that handles everything from sign-ins to security out of the box, so we do not have to build it from scratch. Let's head over to the Clerk documentation. We already have Next.js set up, so we are jumping straight to step 2. Grab that installation command from the docs and paste it into your terminal. It is npm install at clerk/nextjs. While that installs, let's tackle step 3, creating a middleware file. In your root directory, create a new file called middleware.t-s. This file is like a security guard for your app. It intercepts every request to check if a user is allowed to see a page. Now let's copy the middleware code from Clerk and paste it in our middleware file. Now let's move to step 4. Open your layout.jsx file in the app directory. We need to wrap our entire application in the Clerk provider so every component can access the user's auth state. Import Clerk provider from @clerk/nextjs and wrap it around the body tags. Inside the body, right above the children props, we are going to add some UI. let's add a header and a div. And inside, we will import and place the sign in button and the user button from Clerk. For the user button, let's add an appearance prop. We will set the elements object to target the user button avatar box and give it a width and height of 10 to make it look sharp. Next, let's clean up our home page. Open page.jsx and delete everything inside the return. Replace it with a simple paragraph that says "Hello World." At the top of the file, we need to add the useClient directive because we are using hooks. We will import useAuth from @clerk/Nextjs along with useEffect and useState from React. Inside our component, let's destructure isLoaded and user ID from the useAuth hook. IsLoaded is a boolean that tells us if Clerk has finished checking the session, and user ID gives us the unique string for the logged in user. We will write a simple check. If not user ID, then return a div. Inside that div, let's add an anchor tag pointing to /signin, then a break tag, and another anchor tag pointing to /signup. Now we need to build the actual auth pages. Create a folder in the app directory called sign in. Inside that, create a special folder using double square brackets with 3 periods, square bracket, triple dot, sign-in, square bracket, square bracket. This is a catch-all route that Clerk needs. Inside that folder, create page.tsx. Let's write the sign-in page script. First, we import sign-in from @clerk/Nextjs. We export default function sign-in page, and inside the return, we start with a large container div. We give it a flex column layout with a minimum height of the full screen, centering everything with item center and justify center. We add a nice background gradient from background via background to primary with a 3% opacity. Inside that, we create a wrapper for our header. We use an inline flex div for our logo, a rounded full border with the text Career Campus AI. Inside that logo box, we have a small primary colored square with the letters CC for our branding. Below the logo, we add an H1 that says "Welcome back" and a paragraph telling users to sign in to continue their journey. Now for the main event, we drop in the sign in component from Clerk. We are going to customize it heavily using the appearance prop so it matches our app's aesthetic. We hide the default header title and subtitle, and we style the social buttons with a rounded LG border and a subtle hover effect. For the main submit button, we use a beautiful gradient from primary to emerald 500 with a shadow elk to make it pop. We even style the input field to have a primary colored ring when focused. Finally, at the very bottom, we add a footer link that redirects users to the sign up page if they do not have an account. We are going to do the exact same thing for the sign up page. Duplicate that folder structure, but name it sign up with the triple dot sign-up catch-all route. The code is nearly identical. We export default function sign up page. We keep the same flex container and that gorgeous background gradient. We keep our Career Campus AI logo at the top, but change the H1 to say "Start your journey" and update the subtext. When we drop in the sign up component, we pass in the same custom appearance object, so the buttons and inputs look consistent. The only difference here is we add 3 specific props to the component. Routing equals path, path equals /sign-up, and sign-in URL equals /sign-in. This ensures Clerk knows exactly how to navigate between the two forms. At the bottom, we update the footer link to point back to the sign-in page. And that is it. We have a fully secure, beautiful authentication flow ready to go. Now that we have our authentication logic ready, we need to handle what the user actually sees if they are not logged in. We do not want to just show a blank screen. We want to give them a high-end entry point to the application. Now back to the page .tsx. First, we will type a simple check, if not user_ID. Then we open up our return statement. This logic tells the app that if we do not have a verified user session, we should render this landing section instead of the main dashboard. Now, let us start building the UI. We will type a div with a class name of flex, min-height screen, items-center, and justify-center. This ensures our login card is perfectly centered, both vertically and horizontally. We will also add a background gradient to bottom right, starting from background through background to primary /0.03. This adds a very subtle, professional hint of color in the corner. Inside that, let us add a wrapper div with a width-full and a max-width-MD to keep the card from getting too wide on large screens, and we will add space-y-6 to keep our elements spaced out nicely. Next, we will type out our branding badge. This is an inline flex div with a rounded full border. Inside, we add a small flex container for the logo icon. Give it a height and width of 8, rounded LG, and a primary background. We will type the letters capital C inside, which stands for Career Campus. Right next to that, we will add a span with font semi-bold and tracking tight, and type out Career Campus AI. Now, let us build the main card. We will type a div with rounded XL border and a card background with some padding and a shadow LG to make it lift off the page. Inside this card, we start with our typography. We will add an H2 with a font bold and a text 2XL. To make it look premium, we will use a gradient from foreground to foreground /70 and apply background clip text so the color fills the letters. We will type "Welcome to Career Campus AI." Alright, so now below the heading, let us add a paragraph with a leading relaxed and muted foreground color. We will type "Get personalized career guidance and insights to help you achieve your goals." Finally, we need our call to action buttons. We will add a div with flex column and a gap of 3. First, we will type an anchor tag pointing to /sign-in. For the styling, we will use a gradient from primary to emerald 500. This gives it that modern AI feel. Inside the tag, we will add a sparkles component with a height and width of 4, followed by the text "Sign in." Right below that, we will add our second anchor tag pointing to /sign-up. This one will have a background and a standard border to make it a secondary action. We will add a target icon and the text, create account. We are also adding a hover effect with a shadow dash primary /30 to give the user that tactile feedback when they hover over it. And there we go. Now, whenever an unauthenticated user hits our homepage, they are greeted with a beautiful professional entrance. We are making some impressive progress. Now that we have handled the gatekeeping with our authentication check, it is time to build out the actual dashboard experience for our logged in users. We are starting with the foundation of the homepage layout and a sleek, modern navbar. Inside the return statement of our homepage, we are going to start by typing out a div with a class name of flex main-height screen and flex-column. We will set the background to background, add some padding -x of 6 and padding -y of 6, and set the text color to foreground. To make sure this looks great on all devices, we add responsive padding. Next, we will add a wrapper div with m-x-auto, flex width-full, and a max -width of 14-40 pixels. We will also add flex-1 and a gap of 6. This container keeps our entire layout centered and perfectly aligned as the screen gets wider. Now, I want us to quickly work on the navbar. Instead of cluttering our main page, we are going to stay organized. Let us create a new directory inside the parent folder structure called components. Inside that, we will create another folder called home, and finally, a new file called sections.tsx. This file is going to be our main hub for all the homepage components. Let us start by defining the navigation bar. We will type a nav tag with a class name of rounded dash x-l border and border-border. We will set the background to card with padding -x of 4 and padding -y of 3. We will keep the text -sm and add a subtle shadow -sm. For larger screens, we will bump that padding up slightly using sm:/px5 and sm:/py 3.5. Before we go any further, let us import this into the homepage. I am going to temporarily adjust our logic so that even when a user is not logged in, we can see what we are building. And there we have it. You can see that clean floating ring for the navbar showing up on the screen. Let us jump back into sections.tsx and keep working on that navbar content. Inside the nav tag, we will type a div with flex-wrap items-center and justify dash between with a gap of 3. This ensures our logo and menu items stay on opposite ends but stack nicely if the screen gets too small. Inside that, we will create another flex container for the branding. We will type out a div with items-center and a gap of 3. Then we add our logo box. A flex container with a height and width of 8, rounded -LG, using the primary background color. Inside, we type capital C in a bold, small font. Right next to the logo, we will add a div to hold our text. First, a paragraph with text that says Career Compass AI. Underneath that, let us add a smaller paragraph with text, private, personalized, and powered by AI. This gives the app a very professional, high-tech feel right from the first glance. Now let us head back to the home page to see how it all ties together. We are moving fast. Now that our layout is ready, it is time to build the heart of the user experience, the onboarding form. This is where we collect all the data that our AI needs to build that custom roadmap. Let us jump into our sections file and start defining the onboarding card component. We will export a function called onboarding card, and inside the props, we are going to destructure onSubmit is generating plan and generation dash step dash test. We will define the type for onSubmit as a function that takes a user profile and returns a promise of void. Now, you might notice a red wavy underline under user profile. That is because we have not defined our types yet. To keep things clean, let us head over to the source/lib folder and create a new directory called career-type. Inside, we will create an index.ts file to manage all our project types. First, we will type export type task status and set it to a union of not-started, in progress, or complete. Then we define our task type with an ID, title, description, and a category like learning or networking. Next is the month plan type, which includes an index, a theme, a summary, and an array of those tasks we just defined. We also need a plan type, which is just an object containing an array of month plans. Now for the important one, export type user profile. This includes name, current role, years experience, desired role, and strings for time per week, constraints, and challenges. We will also add an app stage type to track if the user is in onboarding or viewing their plan. A chat message type for our AI assistant, Jake. And finally, an app state type to tie everything together. Alright, types are done. Let us head back to the onboarding card in our sections file. We will start by setting up some state. We will initialize all the fields like name and current role as empty strings. We also need a name input ref using use-ref to handle autofocus. We will add a use effect that runs once on mount, calling name input ref.current.focus. This is a small detail that makes the app feel much more professional. Next, we will create a variable called isValid, which simply checks if the required fields like name and desired role are not empty after being trimmed. Now, we will type our change handler. Const handle-change equals an arrow function, taking a field and a value, which calls set-form and spreads the previous state while updating just that one field. For the submission, we will type handle submit. It prevents the default form behavior, checks if the form is valid and that we are not already generating a plan, and then calls our onSubmit prop with the form data. Time for the UI. We will return a section with a rounded XL border and a card background. Inside, we will add a header div. On the left, we will place a target icon inside a primary colored box, and next to it, an H2 that says start with your career destination, followed by a short description. On the right side of the header, let us add a badge that says Step 1 using a sparkles icon. Now, we will type out the form tag, giving it a relative position and a 2-column grid layout for medium screens. Inside the form, we will add a loading overlay. This div only shows up if its generating plan is true. It uses backdrop --blur and animate -spin loader and displays the generation step text to keep the user engaged while the AI works its magic. Next, we build the inputs. For each field, like name, current role, and years of experience, we add a label with a specific icon and a styled input. Notice how we use background /50 and backdrop blur on the inputs. This gives them a glass morphism effect that looks incredible. We link each value to our form state and call handle change on every keystroke. For the challenges section at the bottom, we will use a text area with 3 rows and set call-span-2 so it takes up the full width. Now, let us import this onboarding card into our main homepage. We will provide some test props and a simple void function for onSubmit for now. If you look at the right side of the screen, there it is. Our onboarding form is looking sharp and ready for action. Now that the onboarding form is looking solid, we need to build the other half of our dashboard, our AI career assistant, Jake. But before we do that, let us quickly refactor the homepage to keep our layout precise. We are going to wrap everything inside one main div. This ensures our sidebars and main content align perfectly as we add more features. Now let us create the container for our chat interface. We will type an aside tag with a class name of flex, width full, and shrink 0. For larger screens, we will set the width to 420 pixels using LG:W bracket 420px bracket, and even wider at 460 pixels on extra large screens. We will also add some padding left on large screens to give it some separation from our main roadmap. Let us jump into our components file and build the actual chat panel. We will export a function called Jake Chat Panel. In the props, we are destructuring messages, input, on input change, on send, and is sending. This component needs to be very reactive, so we are passing everything it needs to communicate with our main state. First, we will type const scroll container ref equals useRef of type HTML div element or null. This is crucial for a chat app. We want the window to automatically scroll to the bottom whenever a new message arrives. We will add a use effect that watches the messages array, grabs the scroll element, and sets its scroll top to the scroll height. This keeps the latest advice from Jake always in view. Now for the UI, we will return a section with a height full and a card background. We will use overflow, hidden and rounded XL to keep it looking like a contained widget. Inside, we will add a header with a rounded full primary icon containing the letter capital J. Next to it, we will add an H2 for Jake, your career assistant, and a small caption explaining what the user can ask him. Below the header, we will type a div that acts as the chat box. We will give it a background /60 with a subtle border. Inside this box, we attach our scroll container ref and use the map function to loop through our messages. For each message, we check if msg dot from triple equals user. If it is from the user, we use justify end to push it to the right. Otherwise, we use justify start to keep Jake's messages on the left. Finally, let us build the message input at the bottom. We will type a form and intercept the onSubmit to call our onSend function. Now, let us head back to the home page and import our Jake chat panel. We will pass in some boilerplate props for now, just so we can see the layout, and check it out on the right side of the screen. Jake is officially in the building. We do not have the API connected just yet, but the interface is ready for some AI brains. We are building out the core logic and the beautiful user interface for our AI career planner. We need a way to track where our user is in their journey and visually represent their progress. Let's jump right into the code. First, we will type out our state management. We are using the useState hook from React. We will define a constant, open bracket, state, set, state, close bracket, equals useState. We are passing in a type of AppState which we imported from our career types, and initializing it by calling a function named create-initial-state. This keeps our main component clean by moving the starting data logic elsewhere. Since we haven't defined that initializer yet, let's build it now. We type function create-initial-state, which returns an app state object. Inside the return, we set the stage to onboarding, set the profile and plan to null, and the selected month ID to null as well. We also initialize the chat array with a welcome message from Jake, our AI assistant, using date.now for the timestamp. This gives our users a warm welcome the moment they land on the app. Now, in our main JSX, we need to decide what the user sees. We will add a condition. Open curly brace, state.stage, triple equals, onboarding, or exclamation point, state.plan. This logic check says if we are still onboarding or if there is no plan generated yet, show the onboarding card. Otherwise, in our else clause, we will render the plan section. Let's move over to our new component file and create that plan section. We type export function plan section, and we are going to destructure a lot of props here, like profile, plan, selected month, and several handler functions like onSelectMonth and onUpdate task status. Inside the component, the first thing we do is create a constant called overall, which equals calculate plan progress, passing in our plan. This is going to give us that high-level bird's eye view of the entire 12-month journey. Let's define that helper function, calculate plan progress. It takes in a plan, and if there is no plan, we return 0 immediately. Now for the UI, we return a section tag with some spacing. Inside, we have a card that displays the journey title and a dynamic description. We use optional chaining on the profile. Now back on the home page, let's import the plan section and pass in our state as props to bring it all to life. Alright, let's get into it. We are about to build out the core of our application, starting with the AI and database logic. This is where the magic happens. First, we need to organize our file structure. Inside the app directory, we will create a new folder named lowercase API. Inside that API folder, let's create 3 more folders named chat, plan, and state. We are starting with the chat functionality. So let's go ahead and create a file named root.ts inside that chat folder. Now, before we write the code, we need access to the model. Let's head over to Google AI Studio in the browser to generate a new Gemini AI API key. Once you have that key, hop back into the code and open your .env file. We are going to add a new line here. Type uppercase Google _API_key followed by an equal sign and paste your key right there. Now, let's head back to our chat route file to build the AI functionality. On the right side of my screen, I have the Gemini AI documentation open. I will leave a link for that in the description so you can dive deeper into the details later. To get started, we need the official package. Let's open the terminal and type npm install at google/generative-AI. And just like that, we are ready to start coding the logic. We have our folder set up, our API key secured, and our package installed. In the next step, we are going to initialize the model and handle our first prompt. It is time to bring our AI assistant to life. We are going to build the back-end logic first and then wire up the front end to make the chat interactive. Let's dive into the code. First, in our root.ts file, we need to bring in our tools. We will type import, open curly braces, Google Gen AI, close curly braces, from at Google/Gen AI. Right below that, let's import next response from next/server, so we can send data back to our front end. Now, we need to initialize the AI. We will type const AI equals new Google Gen AI and pass in an empty object for now, since it will read our environment variable. Next, let's define our models by typing const chat models equals, and we will create an array containing Gemini 3 Flash preview and Gemini 2.5 Flash, followed by as const to keep the names fixed. Let's create our main function. We will type export async function post, taking in the request object. Inside, we will start a try-catch block to handle any errors gracefully. First, we extract our data by typing profile, plan, selected month ID, and messages, await request.json. Now for some logic, we need to find exactly where the user is in their journey. We will type const selected month equals plan, optional chain, months, optional chain, find, passing in a function to match the month ID to visualize progress. Let's write a small helper. We type const calculate progress equals an arrow function taken in tasks. Inside, if there are no tasks, we return 0. Otherwise, we filter the tasks where status equals complete and return the percentage using math.round. Using that helper, we will set const month progress by checking if the selected month exists, and if so, calling calculate progress on its tasks. For the big picture, we type const overall progress, where we reduce all the months in the plan to get one final percentage. Now, we need to give our AI a personality. We will define prompt using backticks. This is where we tell the AI, you are Jake, a supportive AI career assistant. We use template literals to inject the user's name, current role, and desired role. We also list out their time availability, constraints, and that overall progress percentage we just calculated. If they have a month selected, we loop through the tasks using map to show Jake exactly what needs to be done. To keep the conversation relevant, let's format the history. We combine everything into const full prompt, adding a final instruction to respond as Jake. Time to talk to the AI. We initialize let reply as an empty string. We will use a for loop to iterate through our chat models. Inside, we try to generate content by calling await AI.models.generate content. If we get a response, we trim the test and break out of the loop. If no models respond, we throw an error. At the very end of our try block, we return next-response.json containing the reply. If anything fails, our catch block logs the error and returns a 500 status code. Now, let's head back to the home page to connect the UI, where we have our Jake chat panel. Find the messages prop and set it to state.chat. For the input prop, we will simply pass input, which is a state we are about to create. Let's scroll up and define that state. We will need input and set input. Now, let's create the logic for sending messages. We type const handle send message equals an async arrow function. First, we call input.trim to clean up the text. If the input is empty or we are already sending, we simply return to prevent double messages. Next, we create the user's message object. We will type const user messages equals an object with a unique ID using date.now, the sender as user, and the content as our trimmed text. Now, we update our UI immediately by calling setState, spreading the previous state and adding our new message to the chat array. We also call setInput to an empty string and set is sending to true. Time to hit the API we just built. We type const res equals await fetch to /API/chat using the post method. In the body, we stringify our profile, plan, and the messages. We use map on the messages to only send the sender and the content to keep the payload light. If the response is not okay, we handle the fallback. We create a fallback message where Jake politely explains there is a connection issue and gives some manual advice. We then update our state with this fallback and stop the loading state. If the request succeeds, we pass the data by typing const data equals await res.json. We then extract the reply text or provide a default one if it is missing. Finally, we create a new message object for Jake and call setState to add Jake's response to the conversation. Now, let's test it out. Everything is looking amazing. The messages are flowing and Jake is giving us that personalized career advice in real time. On the right hand side, I have the MongoDB dashboard open. MongoDB is a NoSQL database which is perfect for our project because it allows us to store flexible JSON-like documents without worrying about rigid table structures. I will provide a link in the description to help you set up your own cluster. But for now, let's walk through it. Once you sign up, create a new cluster and make sure you select the free tier on the far right. After naming your cluster and creating the deployment, a modal will pop up. Go ahead and create a username and password. Then choose drivers as your connection method. We will copy that connection string and head back to our code. Inside your .env file, we will create a variable called MongoDB _URI and paste that string right there. Then let's add MongoDB _DB _name and set it to career _campus _AI. Now let's open our root.ts file. At the top, we will type import next response close curly braces from next/server. Then import auth from @clerk/Nextjs/server to handle our user sessions. Finally, let's import get db from @/lib/mongodb. Wait, we haven't created that library file yet. So let's go into our lib folder and create mongodb.ts. First, type import mongo client from mongodb. We need our credentials. So let's type const URI equals process.env.mongodb _URI. If that URI is missing, you will throw an error saying mongodb _URI is not set. Next, we initialize the connection. Type const client equals new mongo client, passing in that URI. Then const client promise dot equals client dot connect. To make this accessible, we export async function get db Inside, we return await client promise.db, and we will use our environment variable for the database name, or default to career_campus_AI. Now, let's head back to our main route file to finish the logic. First, we set export const runtime equals Node.js. We need to define what our saved data looks like. So we will create type persisted state. This includes our stage, profile, plan, selected month ID, and our chat array. To keep things safe, let's add two helper functions. First, function is object-like, which checks if a value is actually an object and not null. Then, function is persisted state, which acts as a guard to ensure the incoming data has the right structure, checking for the stage, the chat array, and a valid month ID. Time for the get function. We type export async function, get, and start a try catch block. First, we get the user ID from Clerk by typing const open curly braces user ID close curly braces equals await auth. If there is no user, we return a 401 unauthorized error. If they are logged in, we call const db equals await get db. Then we search our collection by typing const doc equals await db.collection user underscore states dot find one, filtering by that user ID. If no document is found, we return a state of null. Otherwise, we return the saved state from the document. Finally, let's handle the post request to save data. Similar to before, we grab the user ID and verify the session. We then extract the state from the request body and run it through our isPersistedState check. If it is invalid, we return a 400 error. Now for the save logic, we call await db.collection user underscore states dot update one. This part is clever. We match by user ID and use $set to update the state and the updated at timestamp. We also use $set on insert to track the created at date only when a new document is made. By setting upsert to true, MongoDB will either update the existing record or create a new one automatically. With this in place, our app now has a memory. Every career plan and chat message is safely stored in the cloud. Alright, let's dive back in. Now we are going to build out the handle onboarding submit function. This is the heart of our onboarding process, where we take all that user data and turn it into a concrete roadmap. Let's scroll down and start by defining our main function. We will type const handle onboarding submit equals an async arrow function that takes in a profile of type user profile. This is an asynchronous function because we will be making a network request to our API. Now, before we jump into the logic, we need to track our loading state. Let's set is generating plan to true. This tells our UI to show a loading spinner or a progress message while the magic happens. Next, we will open up a try catch block to handle our API call safely. Inside the try, we will type const res equals await fetch, calling our /API/plan route. We are using the post method here, adding a header for content type application/JSON, and for the body, we will use JSON.stringify, passing in that profile object. Once we get a response, we need to handle the data. Let's declare a variable letPlan of type plan. We will check if res.ok is true. If it is, we will type const data equals await res.json and cast that as an object containing an optional plan. Then we assign plan equals data.plan. But what if the API fails or returns nothing? we need a solid backup. Before we finish this logic, let's step outside the function for a second and create a mock generator. Up here, let's define const plan generation steps. As an array of strings, these are the messages the user will see, like analyzing your background and building your 12-month roadmap. This keeps the experience feeling interactive. Now, let's build the fallback function. We will type function generate mock plan, which takes in the profile. Inside, we will define const base themes as an array of 12 themes, starting with foundations and clarity, all the way to launch and transition. Next, we create the actual months. We will type const months equals array.from with a length of 12. We use the index to determine the theme. If we run out of themes in our array, we will default to the string month followed by the index focus. Inside this loop, we are defining 4 tasks for every single month. Task 1 is learn and absorb. We use a ternary operator here. If it is the first month, index equals 0. We set the description to focus on clarifying the move into the profile.desired role. Otherwise, it is just a general learning block. We also add tasks for build and practice, connect with others, and reflect and adjust. Each task gets a unique ID, a category, and a default status of not started. Finally, we return the month object, and at the very end of the function, we return the full plan with a unique ID created using date.now. Okay, now let's go back into our main submit function and handle the else case for our fetch call. If the response was not okay, we will type console.error to log the failure and then set plan equals generate mock plan, passing in the profile. Now that we have a plan, whether from the API or our mock, we need to update our global state. We will type set state, taking in the previous state and returning a new object. We spread the previous state, set the stage to plan, attach the profile and the plan, and set the selected month ID to the first month in the array. We are also going to push a new message into the chat array. We will add an object with a unique ID, set the from field to Jake, and write a friendly message. Nice work, followed by the profile.name. We tell them we have mapped out a 12-month path toward their desired role. Alright, let's wire up the UI. We are heading over to our main render and dropping in the plan section component. This is where the 12-month roadmap actually comes to life for the user. We will start by typing out the opening tag, plan section. First, we pass in the profile, prop, which we pull directly from state.profile. This ensures the component knows the user's name and their specific career goals. Next, we add the plan, prop, setting it to state.plan. This is the big object containing all 12 months of data we just generated. Now, we need to handle which month is currently active in the view. We pass in selected month, which is our local constant that finds the specific month object based on the selected month ID in our state. For the interaction, we add onSelectMonth. This is an arrow function that takes an ID and calls setState. We use the spread operator on prev to keep everything intact, but we update the selected month ID to the new ID passed from the component. This is what lets the user click through different months. Next up is on update task status. We are going to pass in our update task status function. If you check the source, this function handles the logic of finding a specific task and toggling its status between not started and completed, while keeping the rest of the plan immutable. Finally, we add on start month and point it to our handle start month function. This is the trigger that officially moves a user into the execution phase for a specific month, likely updating their progress tracking. And just like that, our plan section is fully reactive and synced with our global state. This is it, the final piece of the puzzle. We are going to build a dynamic, high-end header component that adapts as the user moves from onboarding to their personalized plan. Let's start by defining the component. We will type export function header, and we are going to destructure our props, stage and profile. We will also define the types here. Stage is an app stage, and profile is either a user profile or null. Now let's start the JSS. We will open with a header tag, giving it a class name of space y3 to give our elements some breathing room. Inside that, we will create a container for our branding badge. We will type out a div with inline flex, item center, and a rounded full border. This gives us that pill-shaped look. We will use background card /80 for a nice semi-transparent background. Inside the pill, we add a span for the logo, giving it a primary background and bold text, CC, which stands for Career Compass. Next to that, we add another span for the text, Career Compass AI. Now, here is the first bit of logic. We will type curly braces, stage equals plan, and end. If we are in the plan stage, we want to show a special badge. We will add a small separator dot, then another span containing the sparkles icon and the text, AI-powered journey. This gives the user immediate feedback that their roadmap is custom built. Moving down to the main typography section, we will create a div for our headings. For the H1, we are using a beautiful background gradient to bottom right from foreground to foreground /70. We use background clip text and text transparent to make that gradient shine through the letters. Right below that, we have our paragraph tag. Again, we use a ternary based on the stage. If the stage is onboarding, we show a message about building the roadmap. If not, we show a message encouraging them to track their progress and let Jake guide them. Now, let's add the status chips that appear once the plan is ready. We will type stage equals plan and end profile. Inside this block, we create a flex container with a gap of 2. The first chip shows the target. We use the target icon and pull in profile.desired role. The second chip shows the time commitment. We use the clock icon and pull in profile.time per week. These little chips make the dashboard feel personal and data-driven. Finally, we close out our tags. Now, let's head back to our home page to put it all together. Just above our main content area, we will type header. For the props, we pass in stage equals state.stage and profile equals state.profile. And with that, the interface is complete. You have built a fully functional AI-powered career roadmap tool from scratch. We have reached the most exciting phase of the project, deployment. We are going to take this application live by configuring a virtual private server on Hostinger. Let's get started. First, we are heading over to the Hostinger landing page. We will navigate to Services and select VPS Hosting. Pro tip, if you want a massive discount, make sure to use the coupon code ALBERTAI at checkout to grab a killer deal. Once you are signed up and logged in, you will land on this dashboard. We are going to set up our VPS from scratch. Click that setup button. We can choose our server location, let's hit next. And for the operating system, we are going strictly with Ubuntu. Now, we need to create a root password. You can generate one right here, but make sure you copy and save it somewhere secure. It is going to be super important later in the terminal. Hit next and finish the setup. This takes a minute to initialize. So while that loads, let's head over to GitHub. Our goal now is to create a Docker image and push it to the GitHub Container Registry, or GHCR, so we can easily pull it onto our VPS. Back in the console, we are going to use this command. This command tells Docker to build our image specifically for Linux systems without using old cached data, and tags it with our GitHub repository path. Once that build finishes, you can see it in your Docker desktop under Images. Now, to push this to GitHub, we need permission. Go to your GitHub settings, scroll down to Developer Settings, and click Personal Access Tokens. Choose the classic method. Let's name this token Career Campus AI. For the scopes, we need to check the boxes for write/delete packages so we can actually upload our image. Generate that token, copy it, and keep it safe. Never share this with anyone. Now, back in the terminal, we need to log in. Type docker login ghcr.io, enter your GitHub username, and for the password, paste that token we just generated. Success! Now we can push our image by typing docker push followed by that long image name we created earlier. Hit enter and let it upload. Once it is done, you will see the package sitting right there in your GitHub profile. Now let's go back to the Hostinger dashboard. Grab your IP version 4 address. Open your terminal and type ssh root at and then paste your IP address. Type yes to accept the fingerprint and enter that root password we saved earlier. We are officially inside our server. First, let's update our packages by typing apt-get update. Next, we need Docker on the server. Type apt-get install docker.io. To make sure it is running, type systemctl is -active docker. If it says active, we are good to go. Now, we log into GitHub from the server just like before using our username and token. Finally, let's run the app. Type this command and then paste your GitHub package link. This maps port 3001 on the server to port 3001 in our container. If you visit your IP address at port 3000, the app is live. Everything works, the login, the Jake AI assistant. It's all running on a professional production server. Hostinger is a beast for this, so don't forget to use code ALBERTAI for that discount. Thanks for sticking with me through this build. It has been an absolute blast. See you in the next one.